All right, exercise 5D, trig functions of a general angle. We're just doing a few little extra bits in this exercise. And the main thing here that we're doing is looking at, we've already investigated sine, cos and tan x on our worksheets, all right? That was sort of part of this exercise. And knowing where sine, cos and tan are positive and negative, okay? The other thing that I haven't spoken about are negative angles. So we're going to look at the difference between negative angles and positive angles. Now, positive angles are measured, where do they start from? They start from the positive x-axis. See how that's the x-axis and that's the y-axis, and this is where the positive numbers on the x-axis would be. They start measured from the positive x-axis where, clockwise or anti-clockwise? In an anti-clockwise direction. So I'm going to put a 0 here now, but that is the positive x-axis. So don't we have 0, 90, you know, we've been doing this, 180, 270, and 360. And how do we, you know how we write them? We're interested in this angle. I know we're always interested in the acute angles, but this angle is theta in quadrant 1. In quadrant 2, if this bit here is theta, isn't this 180 minus theta? Don't we write our angles as 180 minus theta in quadrant 2? What do we write in quadrant 3? That's right. And the reason the reason this one is called 180 minus theta, you can think of it for quadrant 2, you can think of it in two ways. When I travel to the left, when I travel anti-clockwise, I'm going all the way, say, to 180, but then I'm coming back in the negative direction for theta. See, anti-clockwise, ladies, when you travel anti-clockwise, that's positive direction. And when you travel clockwise, that's negative direction. So when I get to this line, yeah, I can say I'm nearly at 180 and I stopped short of theta, and that's why that's 180 minus theta. But this is really how you're supposed to do it. 180 all the way to the line, and I'm coming back for negative theta. Look, I've gone 180 all the way to the line, and when I travel back clockwise, that's in the negative direction in theta. So it's 180 minus theta. All right, now watching the next one, why is this? You know it's 180 what? Plus theta. The reason is you're traveling in the positive direction all the way. Watch. 90, 180 plus that little bit theta. You know how I was talking about the butterfly, the theta touching the x-axis, right? So that line, the red one, the red arc, is 90, 180 plus theta, because I'm still traveling in the positive direction. And the last one we know is, I'll do that one in black, is 360 minus theta. Why is it called 360 minus theta? Because if you go all the way to the full revolution, you get 360, but then we come back, because we've gone too far, in the negative direction for theta. So it's 360, come back for that minus theta. Okay? Now, the reason we're talking about that is it's really important when you do the negative angles. All right, so we're going to look at the negative angles now. So this is what you've got. Theta, 180 minus theta, 180 plus theta, 360 minus theta. We're going to look at the same angles now in a negative, but we're going to talk about negative angles. So I'm going to go 1, 2, 3, 4. We've got 0. If I'm not traveling anti-clockwise anymore, I have to travel clockwise. So this is called negative 90 when I travel this way. So I've got 0, negative 90. What's this one? 0, negative 90, negative. Good. So 0, negative 90, negative 180, negative, and negative. Yeah, so doing a full revolution in the negative direction. So 270 in the positive angles is the same as negative 90 as a negative angle. 180 this way or 180 that way. 180 and negative 180 are the same position. Okay? Now, All right, so how do I name these angles if I have to go in an anti-clockwise direction? So here's my first one. That's theta, but I've traveled in the negative direction. So this is, instead of 360 minus theta, it's negative theta. So this, if I come to that angle there, it's negative theta. All right, quadrant 3, I'll do in red. Now, what is this angle? Watching. How do I get to that line? To that. I go negative 180, and then I come back in the positive direction for theta. So negative 180 plus theta. Okay, so the quadrant 2, how do I name that? Look where I'm going. I'm going negative 90, negative 180, and negative theta. I'm still going in the negative direction all the way round. So I've got negative 180 minus theta. You okay with this? See how the direction, if you travel clockwise, it's all in the negative direction. And when I had to come back for the red one, I went negative 180 plus theta. Do you see? I went negative 180 to the line, came back in the positive direction for theta. That's why that one is negative 180 plus theta. And the last one, how do I get there? I go, well, I have to go all the way around and come back for that plus theta. So I go negative 360 and then come back in the positive direction for plus theta. Now, so girls, we've got negative theta, negative 180 plus theta, negative 180 minus theta, negative 360 plus theta. Now I want you to look at, compare. What's the difference between quadrant 1 negative angle and quadrant 1 positive angle? That's right. So I took this and I subtracted 360. Look down here in quadrant 4. The negative thetas are the same. All I did was subtract 360 from this one to get that one. Girls, look here as well. I've got minus theta. What's 180 minus 360? Negative 180. So all that the negative angles are is the positive angles minus 360 and gives you all the negative ones. Look at this one. Girls, they're both plus theta, but what's 180 minus 360? Look at the difference between 180 and negative 180. The difference is 360. So what are these negative angles? It's the positive ones. If I take away 360 from that, take away 360 from that, take away 360 from this, and take away 360 from that, all the expressions I get are these on the right-hand side. So all of these are 360 degrees less than that. It's because I travel the other way in the circle. All right? Notice. So what I like, you know how, if you know these, theta, 180 minus theta, 180 plus 360 minus, the thetas are all the same. See, this is still a minus theta, but you don't have to learn them. If you know you start from here, you go negative 180 minus theta, you're still traveling in the negative direction. I want you to know how I got it rather than learn it off by heart. Negative 180, come back for plus theta. The quadrant 1, negative 360, come back for plus theta. All right? All right. Now that's, so these are measured from the positive, positive, that should be direction of x-axis. So measured from the positive direction of the x-axis, but in a clockwise direction. In a clockwise direction. And the other one was anti-clockwise. So they both start from over here, but this one goes anti-clockwise, and that one goes, this one goes anti-clockwise, that one goes clockwise. Now try not to get them confused because they go the opposite way. You know, everyone thinks that clockwise is positive. In this case, clockwise is negative. How are you going to remember? Quadrant 1, x and y are positive, so that's the way to go. That's the normal direction. Up this way. So now what we're going to do, we're going to write the following angles in both positive and negative. So I'm going to give you this one, and I'm going to give you this. I know it's not to scale. I want you to write these as positive and negative angles. I'm trying to trick you by putting some angles in other places. All right. That's a 30, by the way. All right, let's start. So we're going to write them both. We're going to write them as positive and negative angles. All right, let's go. We'll do the positive one in green, negative one in red. Positive goes this way. What is this as a positive angle? You know, starts from here. What is it? Yeah, 40 degrees. And yeah, beautiful. And as a negative angle, you start from the same position. Whoops. And you've got to go all the way around like that to get to it. So 40 and negative 320. Are you okay with that? Now, you don't have to say negative 360 plus theta. You just say I'm going this way and I'm stopping 40 degrees short of a full circle. So I went 320 in the negative direction. I don't sit there and go negative 360. Is it plus theta? Is it minus theta? I don't do that. I draw it and I can see it visually much easier. That's 320, but going that way round. Do you get it?
You know how it's 360 degrees? If it was 180, would it be called a supplement? And if it was 90?
What's this? I know it's not to scale. Go. Positive angle. Yeah, it's 30, even though I'm showing you that there. And the negative angle,
Negative 330.
it is negative 330, and you could have done it as negative 270 and another negative 60, or I'm just 30 short of a complete revolution going the reverse way around. Do you get it? So, you know, 30 degrees and negative 330 degrees are actually the same angle that I'm talking about. Look, I showed you 60 there, so this is 30 here. If you're going in the positive direction, that's positive 30. If you're going in the negative direction, it's negative 330. They're the same thing. I know it's not drawn to scale. What's this one? Positive angle goes this way. Yep, positive angle's 130, lovely. And negative angle is negative 180 and another negative 50. What is it? Negative 230. You know, what do you notice about if you ignore the negatives? 40 and 320 makes 360. 30 and 330 makes 360. 130 and 230 makes 360. But I've gone 130 from this side and 230 from that side to get to the same angle. Okay, so those two are the same thing. 130 degrees and negative 230 degrees represents the same position. All right, what about this one? That's a 30 there, by the way.
240. Oh, wait.
So the positive angle is, what is it? It's 90 and another 30. That's a 30. What have we got? 120. And this, if that's 30 there, then this is 60 here. So I've got 180 and another 60. Negative 240. Got it? All right. So we've got some quadrant 2. We'll do some quadrant 3 and 4 angles now. Go here. I'll put let's stick some 5s in there now. Those two, so I've got 35 degrees there, a 20 here, and I'm going to put 40 degrees there, and I'm going to put a 40 here. Off you go. So I want the positive angle and the negative angle. Positive and negative. Negative. That's a 20 down there. And positive. positive, positive, and negative. Okay? So it's 180 and another 35. What's that? 215. And this one is, well, it's negative 180 plus that. Like it's, you would do 180 minus 35 to get the angle, and it's in the negative direction. So isn't this almost 180 in the negative direction? But it's short 35. So what is it? Negative 145. All right, let's do the negative one first. What do we got? Negative 90 and, yeah, negative 110. And the positive one is 180 and another 70 in here.
250.
Girls, how are we with this? So, what do we got here? 320. And this one, let's just do this while we're here. What about the other one?
310.
Yep, it's 270 and another 40. That's 310. And your last one is, that's coming this way, negative direction. That's negative 40. This one will be negative,
50.
well, because that's 50 there. It's negative 50, but. Okay, so the direction is really important. Are the values to write the ratios of the 6 trig. I'll write down the values for the 6 trigonometric ratios. So write down the values of or for the 6 trigonometric ratios for these diagrams. Now, for example, if I have the point on my circle, negative 3, 4. So that's negative 3 across, 4 up. They've already shown you that the radius of this circle is 5. So that's 3, negative 3, 4 up. So negative 3, 4 up. The length of the hypotenuse is 5. Okay? So I'm in which quadrant here? So I'm going to get rid of, yeah. I'm in quadrant what? 2. So I want the ratios for sine theta, cos theta, tan theta. What are the other 3? Cosec, sec, and cot. Remember these? And how do we remember those? Which letter? Beautiful. The third letter. So the third letter of this one is S, C, and T. So sine theta. Before we start, we've got all stations to central. Only sine is going to be positive. All right. So here's my theta. What's sine theta here? Anyone? You don't have to work out theta. I just want the value of the trig ratio. So give me an expression for sine theta. Opposite over hypotenuse, so it's 4 over 5. Good. Cos theta. Look, I know this length here is 3, but this is in the negative direction. Do you get it? So cos theta, yes, it's 3/5, but cos is negative in quadrant 2. So cos of that angle will give you a negative answer. It's negative 3/5. Even though this distance is 3 and that distance is 4 and this is 5, we know that only the sine ratio is positive in quadrant 2. Tan. What's tan? Opposite over? Toa. 4 over 3, but it's negative. Because it's 4 over negative 3, really. Do you know what I mean? But I just write. You can do your 4 over 3 and then just write the negative. But it is 4 over negative 3. So if you want, put that negative so you don't, 4 over negative 3 or negative 4 on 3 or negative 4 on 3. They're all the same. It's negative. Now, remember that cosec is the reciprocal of sine. So if cos is, you know how we've got all stations to central? Because sine is positive in quadrant 2, so is cosec. So what's cosec? Isn't it the flip, the reciprocal of the sine ratio? 5 on 4. What's sec? Negative 5 on 3. Just put the negative out the front. You know what I mean? And cot is negative 3 on 4. So what you do, you look at it and you say T. Tan is negative in this quadrant, so it's negative, and then do your ratio. Cos. Sec is the reciprocal of cos. Because cos is negative, so is sec. Because the reciprocal means 1 divided by that answer. 1 divided by your negative is still negative. All right, over here, I'm going to do, let's say we've got 2. Let's say we've got -2 and -3. Now I need to work out what if this distance here is 2 and this distance here is 3, but I know they're both negatives. Do you know what I mean? We're going across to -2 and -3. Can someone tell me what the hypotenuse is? 2 squared is 4, 3 squared is 9. What is it? The square root of? 2 squared plus 3 squared. Square root of 13. Okay. Here is theta. Theta always touches the x-axis. And this is the point -2, -3. If you want, you can put your negatives in to help you. So I want ratios for sine theta, cos theta, tan theta, and cosec theta, sec theta, and cot theta. Central, only tan is going to be positive. So sine, that would be -3 on 13. Cos is -2 on root 13. And tan is -3 on -2, which is just 3 on 2. And then cosec is the reciprocal of sine, which is going to be -√13 on 3. Sec is the reciprocal of cos, third letter, -√13 on 2. And cot is positive, 2/3, positive. Because tan is positive, so is cot. Okay? And if I did a quadrant 4 or a quadrant 1, which would be the only ratio positive here? All stations to central. So only cos and sec. And quadrant 1, they're all positive. So you'll be getting those for homework. I'm not doing another one. Do you want another one? If you want, actually, I'll give you something a little bit different. Oh, no. All right. Let's do one. Choose some values. 6 and 7. Positive 6, is this positive or -7? Good. So this is the point 6, -7. You can work out what the hypotenuse is. Square root of. What horrible. Can we do 6 and 5? That might be easier to add. Oh, don't worry. 6 and 7. 36 and what? 49? 50 and 35. 85. Off you go. Sine theta, cos theta, tan. Third letter, cosec, sec, and cot. For cos is positive. What have we got? Sine is -7 on root 85. Cos is 6 on root 85. And tan is -7 on 6. So then the reciprocal ratios, cosec will still be negative. Sec is positive, and cot is negative. Okay? Quadrant 1, if I was to do quadrant 1, everything's positive. All positive.